Hello, this is Dr. Christy Patton Lukes, a chemical engineering professor at Missouri S&T. This is Introductory Transport Phenomenon, a review based on the textbook by Welty, Rohrer, and Foster. We are looking at Chapter 1, Introduction to Momentum Transfer, and we're going to hit sections 1.4 and 1.6 in this lesson, units and surface tension. We are not going to be working exclusively with SI units. I know many students wish that we would. But in industry, we frequently use American engineering units throughout the world. And we need to develop some facility using those. Additionally, we are going to have to deal with mass-based systems and force-based systems of units. Now, there are three primarily that we are going to need to deal with, and they are most easily distinguished by their G sub C. Now, if you recall, G sub C is the unit conversion for converting mass to force. The three systems looked at in this book, the first one is the SI system. Length is meters, time is seconds, force is newtons, mass in kilograms, and G sub C is 1 kilogram per meter is equal to 1 newton per second squared, or G sub C, the quantity is 1 kilogram meter per newton per second squared. And anytime you use that, essentially you're multiplying by 1. We have two, however, American engineering systems. One is force-based and one is mass-based. So let's look at those. System 2 and 3 both, the length is feet and time is seconds, and the force is pounds force. Where they are different is with their mass units. The System 2 here uses slug as the mass unit, and System 3 uses pounds mass as the mass unit. Pounds mass are probably what you're more familiar with, and in that case, G sub C is 32.174 pound mass foot per pound force second squared. But slugs, although they are less common and somewhat out of favor, a slug is more convenient to work with unit-wise, but is not going to have any gut feel reaction for most people. You're not going to just look at the answer and go, oh yeah, that sounds about right. A slug times a foot is equal to a pound force times a second squared. Okay, so a slug is an alternative to a pound mass, and the ratio of the two is 32.174, the traditional gravitational acceleration. The other thing I wanted to deal with in this video lesson is surface tension. Surface tension, we usually use a sigma to designate that, is the effect that causes a meniscus to form in fluids and tubes, right? And we call that the capillary effect. And in water and in most fluids, it's a wetting fluid. And so the liquid tends to wet the walls of the capillary. And so the meniscus is down, okay, as it moves through the tube. And we've always been taught to read the bottom of the meniscus, right? However, there are a few fluids like mercury where the meniscus actually points the other direction. It is a non-wetting fluid, and you read the top of the meniscus in this case. In either case, it's the center is what you're reading. We can calculate the height of capillary rise by saying that it's 2 times sigma, that's surface tension, over rho g r. R is the radius of the tube, times cosine of phi, where phi is the angle that is made between the tube wall and the fluid itself. Okay? And so if you can measure that, then you can calculate the height of the capillary rise. Values of sigma are going to be tabulated in your book. It will vary somewhat with temperature. A lot of times we'll just still call it a constant, but you can look this up in your book for the constant values. And if you want to know the variation in temperature, you need to have a little bit more complete set of data. But for instance, if you want to look and see at what happens with water, the most common one we're concerned with, it's for sigma in Newton meters, the surface tension is 0.123 times 1 minus 0.00139 T. Now, T needs to be in Kelvin in this case. But for this to become an appreciably large quantity, right, that T value would need to be fairly large. So most of the time we can get away with saying that this constant value here is approximately the surface tension that we need to worry with. So that was just a quick look at units, and we'll be learning more about those as the course progresses, and surface tension, which we will use as needed. We have one last lesson in this chapter, and for that we will be coming back and looking at what it means to be compressible in terms of fluid mechanics and momentum transfer. Thank you very much for your time.